Hello, welcome to AP Calculus Section 310, Homework Solutions from page 232. I was able to go ahead and fit 4 of the problems. They're not quite in a row here. At least I skipped ahead to get number 18 because it's so short on the board here, and I can just talk through those, and then I'll work the other 3 in just a little bit. So we want to maximize the revenue in number 3, and here's our revenue equation. So we want to take the derivative of that. That'd be 900 minus 0.2x. Set that equal to 0. Move the negative 0.2x over to the right, and so we have 900 equals 0.2x. Solving for x, that'd be 900 over 0.2, which is 4,500 units. In number 7, we want to minimize the average cost. Well, average cost, you take the cost and you divide it. We call that average cost C bar. You divide each element by x. So if we do that, to get C bar, it would be 0.125x plus 20 plus 5,000 over x, which I'm going to write as 5,000x to the minus 1. So I just took each one of these elements and divided it by x to get C bar. Now I'm going to take the derivative of C bar, and that would be 0.125, the derivative of 20 is 0, and then minus 5,000x to the minus 2. So I'm going to rewrite that as 0.125 minus 5,000 over x squared is equal to 0. And then to solve for the x squared, I'm going to move the 5,000 over x squared over to the right. And then I can bring that x squared out front and put the 1.125 in the denominator. That's just when you have this kind of equation and you're solving for the variable on bottom, you can just replace the variable on bottom with the number out front. So we have that. And x squared then is 40,000. The square root of 40,000 is 200 units. Also, maybe a more proper way to do this algebra is to multiply both sides by x squared, but you end up with the same thing there. All right, in number 11, we have a cost function, a price function, and we want to find the maximum, or we want to find the price that gives us maximum profit. Profit, which is big P, is revenue minus cost, and revenue is then x, the number of units, times the price. So first of all, we need to get revenue, and we're going to do x times the price function. So that'd be 90x minus x squared. Profit is revenue minus cost. We have to be careful to distribute that negative sign across both elements of cost. So that would give us 90x minus x squared minus 100 minus 30x. And now I'm going to combine like terms and bring the x squared out front. I have negative x squared plus 60x minus 100. That's our profit equation. Take the derivative of that. You get negative 2x plus 60. I'm going to set that equal to 0. Solving for x, you would get 30 units. Now that's not the answer. Don't circle that. The price then is 90 minus x. So 90 minus 30 is $60. And then let me skip ahead to number 18. It's so short. 18, we have the profit as and our S value, is advertising dollars. So it's asking what amount of dollars spent on advertising will maximize profit. Okay, so we just take the derivative of the profit equation, which would be 20, derivative of 230 is 0, derivative of 20s is 20, and then 2 times a half is 1, so that would just leave s. 20 minus s is equal to 0. So s is equal to 20, but that's in hundreds of dollars. So we multiply that by 100, and we get $2,000. Okay, hopefully you didn't have too much trouble with any of those. Just pause the video if you need to look at anything a little more closely. I did go a little more side to side with these solutions to get more on the board. But I did that because I didn't think these problems were too awful hard. If you messed anything up, it's probably an algebra mistake. All right, let's do number, 13. So 13, we have C is equal to 4,000 minus 40x plus 0.02x squared. And we have a price function of 50 minus x over 100. Okay, we need to get the revenue so we can get profit. That's x times p, so that's going to be x, little p anyway, x times 50 minus x over 100. So that's 50x minus x squared over 100. Okay, that's our revenue. Profit is revenue minus cost. So that's going to be 50x. I'm going to change this to decimal, minus 0.01x squared minus the cost, which is 4,000 minus 40x plus 0.02x squared. All right, again, if you were wondering where I got the 0.01x squared, I just changed this to a decimal since the x squared term is in a decimal in the cost. Okay, let's distribute and combine like terms here. So I would have 50x minus 0.01x squared minus 4,000 plus 40x minus 0.02x squared. Combining like terms, I'm going to have minus 0.03x squared plus 90x minus 4,000. So we finally got to the profit equation. I'm going to take the derivative of that to find the number of units to maximize profit, so that'd be minus 0.06x plus 90. Set that equal to 0. So I'd have minus 0.06x equals minus 90. All right, so x is going to equal 1,500 units. All right, we need to find the price then. So price is equal to 50 minus 1,500 over 100. Just plugging back into the price equation. And that is $35. All right, let's see if we can fit number 15 in this space here. So 15, we want to use the cost function to find the value where average cost is a minimum. So we have cost is 2x squared plus 5x plus 18. C bar then would be C over x. So if we divide x into each of these terms, I would have 2x plus 5 plus 18x to the minus 1. So I want to take the derivative of that, c bar prime. That's going to be 2 minus 18x to the minus 2. So we're going to set that equal to 0. So that's 2 is equal to 18 over x squared. So solving for x squared, that's going to be 18 over 2, which is 9. So x would be 3 units. 3 units would minimize average cost. So that is part A. Part B, we want to show that the average cost and the marginal cost is 0. Well, the average cost, which is 2x plus 5 plus 18 over x at 3. So C bar, we're going to just plug 3 into that average cost function. So it'd be 2 times 3 plus 5 plus 18 over 3. 6 plus 5 plus 6, that's $17. Marginal cost is just C prime. Okay, so I think I showed it as dC over dx on your formula sheet, but that's just C prime. So C prime is equal to 4x plus 5. So C prime at 3 units is 4 times 3 plus 5, which is also $17. So we were able to show that the average cost and the marginal cost is equal at 3 units. All right, one more to go since we already did number 18. And this number 3 harkens back to 3.9a, number 33, excuse me. We have a revenue function that is 900x minus 0.1 x squared. Okay, and it says use differentials to approximate the change in revenue if sales increase from 3,000 to 3,100. So x, our initial x is 3,000. If it goes to 3,100, that means dx, which is just delta x, is 100. Going from 3,000 to 3,100, that change in x is 100. Okay, so we know that dr dx would be 900 minus 0.2x. So our estimate, which is dr, is 900 minus 0.2x times dx. Here's our differential. Okay? So to get that estimate, how much is revenue going to change if we sell 100 more units? That would be 900 minus 0.2 times 300, 3,000, excuse me, sorry, times 100. So I'm just plugging in right here. Now we use the original x here, not the 3,100. Okay, so when you do that, plug that in your calculator, you get $30,000. So that's the answer. That's what the book is asking for. If you wanted to know the actual change in revenue, it's pretty easy to figure out. That's R of 3,100 minus R of 3,000. So you would just plug in 3,100 units to get the revenue, and then 3,000 and subtract the 2. If you put that in your calculator, you would get 29,000. Didn't ask you to do that, so 30,000 is a pretty good estimate. All right. If we would only done 3,010 units and our delta x was only 10, then it would be a lot closer, the estimate. So 100, you're getting away from 3,000 a little bit there, because the tangent line, the tangent line emulates the actual function at points very close to the point of tangency, right? So 3,100 is pretty close to 3,000, but it's not just right on top of it. So you're not going to get an estimate that it doesn't have a little bit of error in it. Okay, that's it for this video, and I will talk to you on the test review video.